Hey guys, my name is Chelsea Johnson, and this is my strategy talk presentation for concrete manipulative instruction in math. So who developed this strategy? There's no specific developer, however, Maria Montessori can be credited with further advancing the use of manipulatives in education because she saw it as a key part of learning, especially in young children. And the strategy has also been researched and further developed for decades for grades pre-K through 12. So like I said, manipulatives can be used for any grade level throughout any mathematical content, which is really what manipulatives are best for. Some content examples are place value, addition or subtraction. You can use it for multiplication or division, with fractions, creating like equivalents or even all the operations with those, solving word problems, measurement, telling time, geometry, or algebraic problem solving. However, it's not really the best for things like calculus, so in some grade levels there could be a stop to using manipulatives. They're also great for kinesthetic learners and learners with autism or learning disabilities where they like to use like tactile and manipulative like things. When would a teacher use this? So manipulatives are great when you're introducing a new concept, and especially when you're moving from a concept like addition to a opposite operation such as subtraction. They're also great for reviewing concepts, whether you do this as a whole group, a small group, or individual activity, because it gives a student the chance to kind of go back to the basics of where you started with instruction. And they're also great for virtual and computer-based instruction because you can use these as games or as an integrated part of your instruction. Why would a teacher use this strategy? So research shows that students who learn with concrete models typically retain information and perform better when it comes to tests or just their in general work in the classroom. It also gives students a tactile representation of the mathematical functions that they're performing. It caters to being inclusive to many different learning styles. So some students are not exactly like auditory or even just a visual learner. They're kinesthetic learners, so it allows them to touch and perform the functions themselves. And it's also a great way to keep students engaged, especially if they experience things like ADHD. This is a way to keep them hands-on and keep them involved in the instruction. How do you use this model? The first thing you need to do is select manipulatives that are appropriate to the operations that you're performing and to the grade or developmental level of your students. So for example, using 10 sticks for 2-digit multiplication would be much more helpful than using popsicle sticks or gram cubes because that would be units of 1. Next, you're using the manipulatives whenever you're introducing a new concept. So if you're beginning with fractions, you're wanting to show fraction equivalence first, and so you could utilize fraction strips to show how 4/4 are equal to 1 whole. You're providing opportunities as well for students to work in groups with the manipulatives so that they can talk together and make these connections. To find something like 8/8 or 10/10 of a whole is essentially the same thing. You're also needing to provide transition stages to move to representational models. So one example of this would be showing students how to draw out the equivalency models that are similar to the manipulatives that they're using at the beginning of instruction. Like I mentioned earlier, concrete manipulatives is also something that can be used in virtual instruction. It's important to say that it's not a true concrete model, but it really falls somewhere between concrete and semi-concrete, but it still allows students to use a model rather than just a drawing. So they could, for example, say drag and drop to different groups to add or to sort a problem. It can also be used as reinforcement or an integrated part of your instruction. Adjustments for learning disabilities. You may need to give these students more time to work with the concrete models before trying to transition them to a more representational or symbolic model. It's also important to give them one-on-one instruction so that you can make sure that they are building understanding of the relationship between the manipulatives and the content matter as far as the operation that they're performing. For visual disabilities, there are two different categories. For partial impairment, you can use larger and more vibrantly colored manipulatives. And for full impairment, you can use manipulatives with texture or braille printed on them, for example, with fraction strips. Rather than having the numerical 1/4, you would have that represented in braille. And you can also use magnetic manipulatives for a variety of exercises. For hearing disabilities, manipulatives are a great tool because they're visual representations of the operations that they're performing. One other thing is that the teacher could learn sign language for the operations being performed. So you could learn how to communicate to that student that you're adding, you're multiplying, or even, how do you make this equivalent? For behavioral disabilities, these are great for keeping students engaged and stimulated because it's a tactile learning style. I think it's also key to point out to the students that manipulatives are not toys, but instead they're learning tools.